Welcome to Study Loop.
In this problem on the topic of waves and sound, we are given the cross-sectional area of a steel cable and the tension that it is kept under. We are also given the density of steel, and we want to calculate the speed a transverse wave will move along this cable. Now, we know that the speed of a wave on the cable V is equal to the square root of the tension in the cable F divided by the mass per unit length, or the linear mass density of this cable, M over L. Now we are given the density of the material that the cable is made of, which is steel, but we are not given the linear density. We are given the period, the tension, however. So we need to obtain the linear mass density, and we'll go as follows. We know the density of any material is the mass of the material divided by its volume. But the volume of the steel cable is its length times its cross-sectional area. So we can replace V by L times A. So the density then becomes its mass divided by its length times its area. That's the volume of the steel cable. And we can write this as the mass per unit length divided by the area. So this implies, if we look closely at this equation, that the mass per unit length of steel would be the density of steel times the cross-sectional area of the steel cable. So we can substitute this expression into the equation which relates the speed to the tension. And therefore we get the speed of the wave through this cable is the square root, we know, of the tension over the mass per unit length. And we can write this as the square root of the tension F divided by the density multiplied by the cross-sectional area of the cable. And these values are all known, so we can find the speed that a wave would travel through this cable. So the tension is 1 times 10 to the 4 newtons. And this is divided by the density of steel is 7,860 kilograms per cubic meter. And this is multiplied by the cross-sectional area, which is 2.83 times 10 to the minus 3 square meters. All of these values are in SI units, so we get the speed that a transverse wave will move through this cable to be 21.2 meters per second.